My name is Jim Up. I'm a machinist supervisor here at Platform Aerospace, where we provide all CNC applications here. So we currently have CNC machines that we operate on 2 shifts right now. Our machines we have here are a VF2, which is a smaller machine, just a 3-axis. We have a ST30Y lathe with live tooling, which sets us apart from others in the area, which provides us, we can use mill tooling inside a lathe. We have a VF6 that has a TRT 310 trunnion in it, which gives us the 5-axis capabilities. We also have a VF9 that has a large travel, which is 84 by 40 inches, which sets us apart from other applications around here too. We have a UMC 1000 we just got from Haas. This is their latest and greatest machine. It is a large volume, full 5-axis machine, and it's the biggest one they make it right now. It can machine a part that's 34 inches diameter by 28 inches tall. So for us, that's a pretty big deal compared to what we had before. So you can see here on the UMC 1000, our height is actually way higher than our typical machine that we would have here. So that's what actually allows us to be able to machine a much taller part in here than you can on a typical 5-axis machine. Also with this here, you can see our rotation in the B-axis. We can actually rotate 35 to 120 degrees total, which is pretty cool, I think. Also with this machine, we bought the upgraded option for the 1000K through coolant spindle. This is going to allow us to basically run these parts a little bit harder, but keep the coolant in there to keep chips out and also keep our tools cool so they can last a little bit longer and save us some time and money. The VF9 is actually a game changer for us because it allows us to keep all of our parts in-house versus having to outsource to other companies around here. So this actually gives us a large capability of size and dimensions that we can machine. So currently right now we have a tray in there for one of our systems, and it's 50 inches by 32 inches by 10 inches high. So we take a block from about 2,000 pounds down to about only 500 pounds. So a lot of chip removal, but it stays busy and we keep it running almost 2 shifts fully. With us being able to machine out of one block, one solid block, it actually creates a stronger tensile strength in the material itself. And also we can do everything at one time, one operation, versus having to split up in multiple pieces. So with this large part that we're machining on the VF9 now, we are actually able to save a lot of time with this by purchasing unique tooling for this application. So currently right now, that part usually take us about 2 weeks to manufacture. Now we've been able to knock it down to about a week. And really what's allowed us to do that is with custom tooling that we purchased, that's a 90-degree angle tool. So we're able to save from us having to flip a part from basically 5 setups down to 2 setups, and that's it. We have a VF6 here at Platform Aerospace, and actually right now we have a TR310 trunnion in there. So right now, this part here has about a 5/10 without tolerance. It's not very common for us, but we do it on a somewhat regular basis. My favorite aspect of the VF6 is actually the trunnion itself. I think first off, it's fun to run, but also it's a challenge. So programming this is a major challenge for most machinists. So a big misconception with machining is actually that a lot of these parts are a load and go, and that's actually complete opposite of what it really is. So these machines actually require us to take a lot of time and a lot of effort into programming. If we program something wrong, especially with our trunnion, we're going to crash a part, crash a trunnion, cost us thousands of dollars and weeks of downtime. So with us, we try to do a lot of training and keep up on high standards on machining, and that way we can prevent those problems ahead of time. We don't want to cost us more money, or do we want to cost the customer more money either. So here at Platform Aerospace, we have a ST30Y lathe. This is probably one of my favorite machines here. What set this apart is that we have live tooling that we can run on this lathe. And actually, so a good example I usually use when I walk customers around is show them that this here, this is all one operation, one setup. So I can use the lathe, machine this all one setup, take my end milling tool from the mills and cut around here on the side, live tool, part it off, and I have one part, one setup, and I'm done. Usually this application would actually take 2 operations, a lathe on this side, then I have to put it in one of our mills and mill the top side. Where now we can do this one operation, saves us time, saves us cost, and saves the customer cost too. So here behind me we have the VF2. This allows us to machine small parts in a much faster environment than say the 9 or the 6. The rapid's a lot faster and the machining capability is a lot faster as well. We're able to do little parts in a fast amount of time versus using a big machine with large capability. We don't have to do that. we can take this little machine and machine all these little baby parts. The VF2 excels at cutting speed and spindle speed is a lot higher than all the bigger machines. Actually, that saves us time because we're able to run that machine faster and harder in a smaller capacity. So currently right now we're actually machining some handles in the VF2. This could usually be a COTS item from for another system, but for us it has to be a custom-made part for us. So we use a lot of aerospace materials in this environment, and we have to rely on traceability, and that's why we have to basically manufacture this part ourselves. This is not something item you can buy right off the shelf. It's something that we manufacture custom for this door specifically. Here at Platform Aerospace, with all of our machines and especially our machinists, we work directly hand in hand with our aerospace engineers so that way we can make sure we meet all those requirements for the aerospace environment.